Hello, my name's Allan Behrens from Taxal, and I'm with Paul Brown from Siemens. Welcome, Paul. We're here to talk about model-based paradigms. Model-based is very interesting, actually, and there's two sides to the discussion. There's a side really based around 3D design, and then there's the complex systems side of model-based. Today we're going to talk about the 3D design side. Isn't that right, Paul?
Yeah, that's right, Alan. If we focus on that, although I think it's worth actually just having a chat a little bit about the differences between the two. I think that's another situation that we need to think about. The system side being able to is more the front end of the process. So what we will do today is let's talk about how once you've got the definition, once you've got the requirements, and you start doing it, how you can leverage that into the rest of the model-based paradigm using that 3D model to digitalize your processes.
Okay, and I think the other thing is let's try and split this into two areas, and we'll do two parts of this conversation. One around the problem and the problem space, and the other about the solutions and what people are doing and how you can go about actually employing technology to work on model-based within the 3D design side. So let's talk about what the problem is. What is the problem?
Well, I think when you're looking at that whole definition, industries as a whole have grown up using the drawing, the idea of communicating things with sheets of paper, drawings, dimensions. That's been around like forever. I mean, you look back at history, you look at historical drawings everywhere, the whole idea of having drawings and then dimensions on. But the thing about that is it relies on interpretation. It relies on somebody understanding and taking what they see in this 2D plane with bits of extra dimensions on, and then interpreting that. And there's ambiguity. There's ambiguity as people start reading and understanding, and that's becoming more of an issue. The wider things get, the wider businesses get, the more globalization that happens, communicating around, you being able to share that information. And I think that's the crux of the problem, and that's really the background.
Yeah. And this sort of ambiguity leads to breakdown in quality and communication, collaboration, things like that, doesn't it? I mean, it's
well, yeah. And if you think about it, in the past, when companies were more vertically integrated, it was easy. I mean, my background was I did an apprenticeship, I trained to be a design draftsman, and so I worked on the factory floor as well as working up in the drawing office. And if we had a problem with a drawing when we were on the factory floor, it's easy. You either pulled the designer down and spoke to him, or rung them up and got some clarification. But now, the problem, as businesses have become more distributed, as more suppliers in the supply chain, outsourcing of manufacturing, that's not so easy, because one of the biggest problems you outsource a design to maybe the other side of the world, which is perfectly normal now. Well, if there's any ambiguity there, I have to wait for clarification. I may have to wait 8 hours or 12 hours. Well, that delays my whole schedule. It can be a complete day or even 2 days before I get clarification. It's 2 days into the schedule, more time, or I take a gamble and I interpret what I think is right, in which case then I'm risking potential quality, rework, cost. So there's a lot of things that can come from that ambiguity.
And it's not, I think, just to be clear, it's not really just about this 2D information. It's about, I think, this new world of product information that you want to actually package into the communication and collaboration area. It is really about things like tolerances and boundary conditions for analysis. It's not just 2D data. This is a 3D model with everything about it packaged in with it, including dimensional data, surface finishes, tolerances, paint effects, things like this, isn't it?
Yeah, well, I think that's another key point is since about the 50s, people have been very used to having symbology on a drawing as well. So in engineering terms, having things like geometric dimensioning and tolerancing, often people call it GD&T. So a symbol that allows you to identify some tolerances, dimensions with tolerances, that all gives all about the fit of something. But to manufacture a part, to actually build a product, you need so much more than just the dimensional sizes. As you say, you need things like the material specs, hardness. If things are welded, you need the welding parameters. If things, how things are connected together. So there's so much more information, which is why increasingly we're moving into this world where there's a predominance of product and manufacturing information. You'll hear the term PMI, which is, say product and manufacturing information, and that's that broader scope. That's that embedding more knowledge, more information into the 3D model, such that that becomes the master and effectively the true digital twin of the components that you're making down on the factory.
And it's not as though we haven't had this information before. It's just come from different sources. And again, this sort of the ability to pull it together and attach it to the 3D model is really what we're talking about here.
Absolutely, absolutely. Because a lot of times the data's resided in all different locations, and you've had to interpret it and bring it back into what does this mean to the design. Having it on the master model onto to be able to use that digital twin of the product, interrogate it, and then share it around. It allows you to make it easier. And of course, being very graphical, that master model as a basis for interrogation, navigation, it removes a lot of that ambiguity, because I can pick things and see exactly what tolerances, what material, what finishes, do I need specific tooling for a particular part of this model because it's got these feature characteristics.
And this isn't just specific to big or small, big companies or particular industries. I mean, this is a problem across all.
This is a problem across all, and in fact, when you look at the types of businesses that have been deploying and looking at these types of technology, you see this mix. Obviously, the larger companies have more people touching the data, but then also the smaller companies are actually often feeding information to the large companies and inside the company. So it actually affects everybody. The whole supply chain and connection together is important in this case. So big, small companies each have uses for being able to move into this model-based environment to be able to move forward.
Good. So, so the problem really, going back to the nub of it, is about creating an unambiguous information source based on a 3D model.
Absolutely.
So let's move on in a couple of minutes to the solutions.
Okay, let's do that.